This is Dr. Ganesh Naidu, Assistant Professor, CS based department. Today I would like to discuss on Introduction to Database Management System concept. Introduction to database design process steps. So requirement analysis, conceptual database design, that is ER diagrams, logical database design, that is a relational model, schema refinement, that is normalization, physical database design, that is storage of data, how you are storing the data, application and security design, that is after storing the data, how you are providing indexing to the data. Number of tables are there, thousands of tables are there. Okay, so which table you need, from which table you need to collect the data, you have confusion. So for that you will maintain an index. That is, you should maintain an index. Okay, that indexing, where you are applying the security, these all comes under final design step. This is the database design process. Okay, database design process. So first, requirement analysis is nothing but what are the requirement to create the database? So means what data you are storing in the database, what are the operations you are performing on the database, what are the data you are storing in the database, how much space is needed to store the data in the database. Next, what are the applications built on the database, who are the end users for the database. So these all are the requirements. Before making database, creating database, you have to analyze all these. How much space it will need. Okay, how much space it is needed, how much memory it will take, next how many users will access the data. So there is a diversity of applications. These are all the requirement analysis. Conceptual database design. Once if you have finished which data you need to store, which details you need to store, for which data you need to create the database. If you store, if you collected all the data in requirement analysis, then you will go for design. The data you collected, you will design in a diagrammatic format. That is nothing but conceptual database design. Conceptual database design is nothing but ER model. So ER diagrams, you will represent the data in the form of diagram. For any case study, it may be hospital management system, it may be college management system, so it may be library management system, any case study. So you will represent the data in the form of ER diagram. For example, for college management system, entity is nothing but here each and every real world object is an entity. In college management system, student is an entity, faculty is an entity, principal is an entity, directory is an entity. So like that. Okay, so any real world object is an entity. Okay, so these entities, how they are related to each other, how they are connected to each other, that we can represent using relationships. Student connected to faculty by using relationship called guides. The faculty guides student, student guided by faculty. So that guides guided by is the relationship. Like that, you are having ER diagrams, different entities and how they are connected to each other by using relationship. The relationship is nothing but two entities, how they are connected to each other. Okay, so another example, customer is an entity, product is an entity. Customer purchases product or customer purchases item. So this customer, item are entities, purchases is the relationship. Like that, entities and relationships are there. So we will discuss in depth in later classes. Logical database design. Here, logical database design is nothing but what you have drawn diagrams, no? ER diagrams, entity relationship diagrams based on the requirements which you collected. That for any case study, that may be library, hospital, I am telling anything. Okay, so for any case study you collected and you drawn some architecture diagrams, ER diagrams. Those ER diagrams should be converted into tables. Each and every entity is converted into table. Each and every relationship is converted into table. Each attribute is nothing but column in the table. So like that, you have to convert ER model into relational model. That conversion of ER model into relational model is nothing but logical database design. Next, so in that is logical database design step is nothing but relational model. It gives the relational model from ER model to it converts all entities and relationships into tables. Those all tables are connected together and it will gives the database, okay, or relational model, that is database. Okay, simply this database is output from the logical database design. Schema refinement is the fourth phase in the database design process. Okay, database design steps, it is the fourth step. Database you got, it is a collection of tables. It consists of number of tables, all are related to each other. That is okay, that is good. Next, schema refinement means the tables are having problems. So that is the tables may consist of erroneous values, illegal values, that is inconsistent values, not related values, irrelevant values, I can say, erroneous mistake values, which are not appropriate values, those and not suitable values, not allowable values. For example, what I can say is means how you can give age. You can give age as 20 or 30 or 40 like that. If in the age column, if you have given Ganesh like that, is it appropriate? It is wrong. It is inconsistent value. It is not correct, no? So that mistaken values. Okay. So these are all erroneous values, exceptional values, exceptions, runtime errors, anything which is not possible to maintain. Okay. So these all can be removed, mainly the repeated values. Okay, in database we will face a major problem with the repeated values. Why? Because anywhere the data is repeated means we will get confused that is related to which particular record. In a student record, if you are having multiple repeated values, okay, without any unique identifier, if you are having multiple values, multiple redundant values, repeated values, okay, so in a class 10 students are there having name as Ganesh. So 10 students are having same name as Ganesh. So okay, you have to identify them by using roll number. So without roll number, you cannot identify which student you are addressing. In 10 names, 10 students having same name as Ganesh. Okay, so if you stored, that is one is Ganesh Kumar, one is Ganesh Babu, one is Ganesh Naidu, one is Ganesh Reddy, like that you are having different names. You saved their student name simply as Ganesh. So in 10 rows you stored a name as Ganesh. Then you need to retrieve the data. You need to call one student, particular Ganesh Naidu, you have to call. So that particular student is a class topper or is having more than 9 CGPA. So particular person you would like to okay, so you would like to consider for some internship or some placement purpose, you are promoting that student. So in 10 rows, which is that particular student, without unique values, you cannot get the clarity or maintaining the data. Okay, so is difficult. The consistency is lack here. That is the problem with the repeated values. With the repeated values, you are having so many problems. When you are inserting some value for the particular person, which person you need to insert the value, which person you need to update the value. If repeated values are there, you are having several problems. Those are nothing but anomalies, we will call it as. Okay, so the like that you are having different problems in the database. That database problems are nothing but these are all things which I have discussed. Okay, so repeated values are inconsistent, erroneous values, illegal values, exceptional values, empty values, null values. All these different problems are there. No? So this can be rectified. Schema refinement means these these tables can be rectified. These tables problems can be rectified. Okay, so these tables having problems or mistake values, now those can be corrected in schema refinement. Schema refinement is nothing but it uses a powerful theory called as functional dependency, decomposition, and normalization. These are the powerful theories, elegant theories, okay, to rectify the problems in the tables. In the tables, you are having different problems which I discussed. Those can be removed by these powerful theories: functional dependency, next normalization, next decomposition. These are the three powerful theories. So each and every theory, what it says, how it will be implemented, those we'll see in further. Next, physical database design, storage. Okay, so after rectification of problems in the tables get purified. Means tables not contain any mistaken values, any erroneous values, irrelevant values. There is a purified data, completely appropriate, correct data, 100% correct data. So that data is stored in the physical database. Okay, how it is stored, that can be taken care by the physical database design. So how we are storing the data in the database. Next, application and security level design. So in this design, you will concentrate on who are the end users. So in which application you are using this database. Okay, so student database I am using in the university application. Next, faculty database I am using in the college management system, university management system. Okay, like that. So customer, where you are using in the e-commerce category. Okay, product or item, so you are using in the e-commerce category, like that. Different applications where you are using this database. And security design, different security mechanisms there, no? So in DBMS, those security mechanisms you can use. Okay, so you can give permissions to the people whom you need to give the permissions, to people who can access the data, people who should not access the data. So you can give the permissions based on that authorized access data. Okay, so that you can support with the DBMS. That can be done in the last step. These are the database design steps.
Like, share and subscribe. Hit the bell icon for more updates.